In this lesson, we're going to talk about how to graph absolute value functions using transformations. So this is going to be the parent function of the absolute value of x. So basically, it's a graph that looks like a V, pointing in the upward direction. Now, if you want to plot it using points, here's what you need to do. The center is 0. So you want to choose 2 points to the right and 2 points to the left. And then plug in the numbers to find the y value. The absolute value of 0 is 0. The absolute value of 1 is the same thing. It's 1. The absolute value of negative 1 is positive 1. And the absolute value of negative 2 is positive 2. And then you can plot the points. If you do that, you're going to get a graph that looks like this. Now what about the absolute value of negative x? Let's say if the negative is on the outside. How would the graph look like? If the negative is on the outside, it's going to reflect over the x-axis. So instead of opening in the upward direction, it's going to open downward. Now what if the negative is on the inside? If it's on the inside, it doesn't matter. It's still going to open upward. The absolute value of any negative number will produce a positive result. For example, if you plug in positive 1, absolute value of negative 1 will still be positive 1. So the negative on the inside will not cause the graph to open downward, but the negative on the outside will. Now, what are the domain and range of these two functions? The domain represents all of the possible x values. As you can see, x could be anything. The lowest x value all the way to the left is negative infinity, and the highest is infinity. So it's all real numbers for the domain. You can plug in any value into x. Now what about the range? The domain for the other one is the same, by the way. It's negative infinity to infinity. That's going to be true for all absolute value functions if there's no fractions, no radicals, no logarithmic equations. It's going to be all real numbers. Now as for the range, what's the lowest y value that we see in the graph on the left? Notice that it goes down towards negative infinity, and the highest y value is 0. So the range is from negative infinity to 0. Now, for the graph on the right, the lowest y value is 0, the highest is infinity. So the range is from 0 to infinity. And 0 is included, so we need to use a bracket instead of a parentheses. Now what about graphing an equation that looks like this? This graph is going to shift 2 units to the left. And so it's going to open upward because there's a positive outside of the absolute value function. Now if you want to plot points, you need to realize that the slope is 1. So once you plot the vertex, as you travel 1 unit to the right, go up 1 unit. So that will take you to the point negative 1, 1. And as you travel 1 unit to the left, go up 1 because the slope is 1. On the right side, the slope is positive 1, but on the left side, the slope is negative 1. And then to find the next point, travel 1 to the right and up 1. And the left side is just going to be a reflection of the right side. So the graph is going to look like this. If there was a 2 in front, the slope will be 2. The graph would be like more steeper, so to speak. It would be narrow and not as wide. Now what about the graph for this one, x minus 3? This one is going to shift 3 units to the right. And it's still going to open in the upward direction with a slope of 1. Now what about the absolute value of x plus 2 and also negative absolute value of x minus 3? What's going to happen to the graph? In the first example, it's going to shift up 2 units, and because we have a plus sign in front, it's going to open in the upward direction. For the second example, is going to shift down 3 units. That's a vertical shift. Left and right represents a horizontal shift. And it's going to open downward due to the negative sign. Now, what are the range for the graph for each of these? Let's start with the first one. What's the range? Notice that the lowest y value is 2, the highest is infinity. So the range is going to be from 2 to infinity, and 2 is included. Now for the one on the right, the lowest y value is negative infinity. The highest is negative 3, and negative 3 is included. So the range is from negative infinity to negative 3. You start from the low y value and you stop at the highest y value. And there's no breaks in between. So what if we have a combination of transformations? Let's say this graph. So it's going to shift 2 units to the right and up 3 units. So here's the vertex. And it's going to open upward with a slope of 1 to the right and with a slope of negative 1 to the left. By the way, for those of you who prefer to use tables, here's what you want to do. If you set the inside part equal to 0, this will give you the x-coordinate of the vertex, which is 2. After that, you want to make that your center point. Choose 2 points to the right of 2 and 2 points to the left, and find the y values at those points. When you plug in 2, y is going to be 3. When you plug in 3, the absolute value of 3 minus 2 is 1 plus 3, that's going to be 4. If you plug in 1, it's going to be the same thing. If you plug in 4, 4 minus 2 is 2 plus 3 is 5. If you plug in 0, you're going to get the same thing. And once you plot it, you're going to get a graph that looks like this. The domain for that graph is all real numbers, but the range, the lowest y value is 3, the highest is infinity. So the range is going to be 3 to infinity. Try this one. 4 minus the absolute value of x plus 1. So the graph is going to shift 1 unit to the left, and it's going to shift up 4 units. So the vertex is at the point negative 1, comma 4. And the slope, the number in front of the absolute value function, is 1. And because there's a negative sign in front of it, we know it's going to open in a downward direction. But let's plot points though. To get the next point, as you travel 1 unit to the right, you need to go down 1. Same thing, 1 to the left, go down 1. And then 1 to the right, go down 1 again, and just repeat the process. And so this is going to be a rough sketch of the graph. And I missed all the points there. So that's how you can graph it if you want to draw a more accurate sketch using points. And as we can see, the range is from negative infinity to 4. The highest y value is 4. And don't forget to put brackets because it includes 4. Now let's try one more example. So let's graph this one. So this time the slope is going to be 2. The graph is going to shift 1 unit to the right, and it's going to shift up 3 units. So it starts at the point 1, 3. As we travel 1 to the right, we need to go up 2 units on the y-axis. So the next point is over here. 1 to the left, we need to go up 2 units. And as we travel 1 more unit to the right and 1 to the left, we need to go up 2 more units, but I'm out of space, so I'm just going to have to go with this. Because I'm out of space, let's do one more example. So let's say if we have 5 minus 3 x minus 1. So I'm going to put this over here and draw a bigger graph this time. So as we travel 1 unit to the right, we need to go up 5 units. Based on this, it shifts 1 to the right horizontally and vertically up 5 units. So the first point is at 1, 5. Now we have a slope of 3, and because it's negative, we know it's going to open downward. So as we travel 1 unit to the right, we need to go down 3 units. 5 minus 3 is 2. So that will take us to the point 2, comma 2. And then 1 to the left, we need to go down 3 units. So that's the point 0, 2. And then if we go one more to the right, we need to go down 3 units. 2 minus 3 is negative 1. So we'll get this point here and another one here. And if we go one more to the right and one to the left, we need to go down 3 more units. So the graph is going to look something like this. So now you know how to graph absolute value functions.